question 277, find the celebrity from LeetCode. Suppose you're at a party with n people labeled from 0 to n minus 1, and among them there may exist one celebrity. What is the definition of a celebrity? A celebrity is that all the other n minus 1 people know the celebrity, but the celebrity doesn't know anyone. Return the celebrity label if there is a celebrity at the party, and if not, return 1. So basically, this question is a graph question, and we are supposed to find a node that doesn't see any other nodes other than itself, but all the other nodes can see that node. So let's go through some examples so you can understand this. So in example 1, as you see, we have node 1 that cannot see any other nodes here except itself, but other nodes can see node 1. As you see, 0 can see node 1, 2 can see node 1, and node 1 can see itself. But node 1 doesn't see any other nodes. And if we want to see the array, the matrix that shows these connections and the number of nodes, so in this list we have 0, 1, 2 list. It means we have 3 nodes, and each node index indicate the connection that nodes has with other nodes. So as you see, at index 0, node 0 has connection with node 0, and at index 1, node 0 has connection with node 1, and at index 2, node 0 has no connection with node 2, and so on. And as you see, we return node 1 as a celebrity because it can see itself but no other nodes, but other nodes can see node 1. And in the second example, as you see, we have 3 nodes, and each node can see at least one more node other than itself. And this indicates that there is no celebrity here, and that's why we return -1. So let's jump to the code and see how we can solve this problem. One way it comes to my mind is we can iterate over the list that is given to us with the connection for each node and see if that node, if it can see any other node, so it means that that node cannot be the celebrity. And in the question, a function is given to us called knows, so we don't need to go through this list and see if there is a connection or anything like that. We can use this given function called knows. So we can just pass on to node's number and see if this node can see the other one. So the first one is the one that we want to check if it can see the second node, right? So by using this node, we don't need to go through this list, and the function knows will take care of that. So by using that, what we can do, we can start iterating over this list and find the possible candidate. So for the beginning, we start from node 0. We consider node 0 as a possible candidate. And then we iterate over nodes and see if there is a better, like there is a correct candidate, and we update the candidate number. So we start from index 0, we assign it to candidate. So then for the for loop, we start from index 1 to n, and we check by using knows function if that candidate, which is 0 now, for this case, 0 can see index I, which start from 1. So we check if 0 can see 1. 0 can see 1, and if it can see 1, we are going to update the candidate to I. So now the candidate is not 0 anymore, it's 1. And we go through the for loop, and now the candidate is 1 and n is 2. We check if 1 can see 2. It cannot see 2, we don't go through this if, and now we check if 1 can see 3, and 1, it can see 3, so we are going to update the candidate from 1 to 3, and there we go, we are done. You might say, okay, this way we know the candidate and we should be done, but there are some edge cases, some special cases, like the one that you see here. Every other node can see itself and the other node, so there is a like loop here. And how can we handle these cases? What we can do is, after going through this loop, we can see if the node that we have chosen, which is like, for example, in this case, we are using the last index, and we don't know if these 3 like possibly can see 1, and 3 can see 1, so 3 cannot be the candidate, so this like we cannot return that as a result. What we can do is we can check all the previous nodes until the candidate, and see if the candidate can see any of them. And if candidate can see any of them, so when this is not the right case and we don't have any celebrity. So let's consider like 3 can see 1, right? So we are going to check from I to the candidate and see if any of these cases are true. So we check from the candidate is now 3, we check index 0, 3 cannot see 0, so that's good. Then we check 3 and 1, and 3 can see 1, so we are going to return -1 because we know there is no celebrity. And there are cases that to make sure that like we don't have, like there are cases that we have loops. So what is this kind of cases? So what we can do is we can check every single I with the candidate and see if there is a connection with the candidate, and if there is, what we're going to do, we are going to return -1. So as we know, each candidate can see itself too, so we are going to check if there is a node that cannot see the candidate, so it means we don't have a celebrity. So in this case, we start finding the candidate, and then we see there is a loop, and we are going to return -1. And the time complexity for this, because we have like 3 fours, but each one is n, so it's going to be 3 n's, and the overall time complexity is going to be linear. And the space complexity is 1 because we are not using any extra